are statically indeterminate. We will also try to determine the unknown reactions by applying the equations of equilibrium. Let's start!
Okay, so for our first problem, 3.1 letter A, we have here a beam that is supported by a hinge and a roller. So yung hinge, meron siyang dalawang reaction, tsaka yung roller is isa. So we have a total of 3 external reaction. So R is equal to 3, meaning this beam is statically determinate. For letter B, we have here another beam that is supported by one hinge and 3 rollers. So hinge has 2 reaction and roller has 1 reaction each. So we have a total of 1, 2, 3, 4, 5. R is equal to 3. We have a total of 5 external reaction which is greater than 3. Therefore, this beam is statically indeterminate. So let's find the degree of external indeterminacy. Degree of external indeterminacy can be found using this formula. External reaction minus 3. 5 minus 3 is equal to 2. Therefore, this beam is statically indeterminate at second degree. For letter C, we have here a frame that is fixed on both A and B and has 2 internal hinge. So, pag fix siya, meron siyang tatlong reaction. And R is equals to 3 plus EC. Yung EC, ito yung internal hinge dito. So, 3, 6 is equals to 3 plus 2. So, 5 yan. Meaning, 6 is still greater than 5. 6 is greater than 5. Meaning, just like letter B, this is statically indeterminate. So, let's find the degree of external indeterminacy. So, R minus 3 plus EC. Yung external reaction is 6 minus 5 equals 1. Therefore, this is statically indeterminate at first degree. Okay, so letter D na tayo. So this beam is supported by one hinge and a roller. It also has one internal pin. So hinge again has 2 reaction, roller 1. So R is equals to 3 plus EC. Yung external reaction is 3 equals to 3 plus 1. So less than na to. 3 is less than 4. Therefore, this beam is statically unstable externally. For 3.32 letter A, we have here a cantilever beam that is fixed on the left side and is supported by a roller on this side. So, pag fix, meron siyang 3 reaction. And the roller is 1 each. So, R is equals to 3 the total number of external reaction is 1, 2, 3, 4, 5, and 5 is greater than 3. Therefore, this is statically indeterminate. So let's find the degree of external indeterminacy. i.e. is equals to 5 minus 3, 2. Therefore, this is statically indeterminate at second degree. For letter B, we have here another cantilever beam that is supported on the left side, and it is fixed, meaning may tatlo, at dalawang roller, at saka dalawang internal hinge. So, R is equal to 3. The total external reactions are 5, and plus 3 plus total number of internal hinge is 2. So, 5 is equal to 5. Therefore, this is statically determinate. So, letter C na. Sa letter C, meron tayong frame that is fixed on both point A and point B. Pag fixed, meron siyang tatlong reaction each. So, R is equals to 3. Total number of external reaction is 6. 6 is greater than 3, therefore, this is statically indeterminate. So, let's find again the IE, or the external indeterminacy, or degree of external indeterminacy. 6 minus 3 is equal to 3. Therefore, this frame is statically indeterminate externally indeterminate at third degree. And next, for letter D, we have here an arc with fixed support, the points A and B, and one internal pin or hinge. So, R is equals to 3 plus EC. R, external support is, since fixed, so there is 6, equals to 3 plus 1 EC. So, 6 is greater than 4. Again, this is statically indeterminate externally. So, let's find the degree of external indeterminacy, i.e. 6 minus 4 is equals to 2. Therefore, this is statically indeterminate at second degree. And lastly, for our 3.32, letter E, we have your gabbled frame that is fixed on this side and is supported by a hinge on this side, and it also has 2 internal hinge. So for that, R is equals to 3 plus EC. We have 1, 2, 3, 4, 5. 5 external reaction is equals to 3 plus number of hinge is 2. So 5 is equals to 5. Therefore, this frame is statically determinate. For 3.3, letter A, we have here a beam that is supported by 1 hinge and 3 roller. So, hinge has 2 reactions, and roller has 1 reaction each. It has also 3 internal hinge. So, R is equals to 3 plus EC. E sub C. Total number of external reaction is 2, 3, 4, 5. 5, and for EC, or E sub C, you have 3 plus 3. Therefore, it is greater than 5. So, 5 is less than 6, meaning this beam is statically unstable. For letter B, we also have again this beam that is supported by one hinge and two roller with two internal hinge. So R is equals to 3 plus EC. For total number of our external reaction, we have 1, 2, 3, 4. 4, 3 plus EC, 2. So 5, meaning 4 is less than 5. 4 is less than 5, then this is also statically unstable. For letter C, we have here an arc that is supported by hinge. So hinge, therefore, R is equals to 3. If it is hinge, then 4, it has 2 reactions each. So 4 is greater than 3. If 4 is greater than 3, then this arc is statically indeterminate. So let's find the IER, degree of external indeterminacy. 4 minus 3 is equals to 1. Therefore, this arc is statically indeterminate at first degree. And lastly, for 3.3, we have here a gable frame that is supported by hinge and has 2 internal pins. So 3 is equals to 3, R is equals to 3 plus EC. So the number of our external reaction is 1, 2, 1, 2. We have only 4 external reaction. And further, for EC, we have 2. So 3 plus 2 is equals 5, therefore 4. 4 is less than 5. Hence, this frame is statically unstable. Letter A. So we have here a beam that is supported by one hinge and two roller. Hinge has two reaction and roller has one reaction each. So 3 R is equals to 3. Our number of external reaction is equals to 4 and 4 is greater than 3. Therefore, this is statically indeterminate externally. So, let's find the degree of external indeterminacy. 4 minus 3 is equals to 1. Therefore, this beam is statically indeterminate at first degree. Okay, next, you have here a frame that is supported by two hinges with two internal pins inside. So, R is equals to 3 plus the internal hinge EC. The number of our external reaction is 4. 4 is equals to 3 plus 2. 4 is less than 5. Therefore, this frame is statically unstable. Let's proceed to letter C. This frame is fixed. So, pag fixed siya, meaning meron siyang tatlong reaction each. Now, R is equals to 3. So, 6, ang ating external reaction X is, 6 is greater than 3. Therefore, this is statically indeterminate. So, hanapin naman natin yung degree of external indeterminacy, i.e., 6 minus 3 is equals to 3. Therefore, this frame is statically indeterminate, externally indeterminate at third degree. And lastly, for our 3.4, we have here a gabbled frame that is fixed and has three internal hinge rather. So, R is equals to 3 plus E of C. Our external reaction is 6 and 3 plus EC, which is 3. 6 is equals to 6. Therefore, this frame is statically determinate. And that's all for static determinacy, indeterminacy, and instability. For our first problem, in equilibrium and support reactions, we have here problem 3.31. An arc that is supported by hinge in point A and point B, and meron siyang internal hinge sa point C. Meron ring uniformly distributed load na 30 kN per meter, tsaka horizontal load na 200 kN to the left. So, apat yung ano natin dito. But before we start, para maghanap ng mga unknowns is, unahin muna natin i-classify kung determinate or hindi ba itong structure na to. So, R is equals to 3 plus EC. Our external reaction is 4, and 4 is equals to 3 plus isang internal hinge, so 1. 4 is equals to 4. Meaning, this structure, this arc is statically determinate. So, pwede na tayong mag-start. We can start determining the unknown reactions by applying the equations of equilibrium. So, magmo-moment tayo sa B para makuha natin yung AY. So, counterclockwise is positive. Summation of moment at point B is equals to 0. So, AY, yung moment arm is 24. Since clockwise siya, magiging negative 24. Negative 24, AY, then AX 0. So, diretso na tayo sa 30 kN. So, 30 kN, yung ikot niya is counterclockwise, meaning positive 30 kN, tsaka yung area na 12 multiplied by moment arm from 12 divided by 2, so 6 plus 6 plus 12 divided by 2, 18. And then, yung sa 200 kN, since counterclockwise pa rin yung ikot, so magiging positive. Positive 200 kN times moment arm na 10.4. So, solving for AY, so diretso na natin. Negative 30. Oh. 30 times 12 18 plus 200 10.4 divided by negative 24. The answer is 356.67. 356.67 kilonewton and upwards since it is positive. Now, kasi nagamit na natin yung moment sa point B, maghanap naman tayo ng ibang point para makakuha naman ng isang unknown. So, dito tayo sa point C, sa segment AC. Okay. Counterclockwise is positive, summation of moment, segment AC, moment at C is equals to 0. Okay. Yung sa AX, moment arm niya is 12. So, and yung ikot is counterclockwise, so positive. 12 AX, AY, yung ikot is clockwise since, so, negative. Negative AY, 356.67 moment arm na 12 plus eto sa uniform distributed load since counterclockwise yung ikot, so positive 30 times area niya na 12 at yung distance from resultant niya to point C, so 6. Now, solving for AX, 356.67 times 12 minus, negative na yung pag-input kasi inassume na natin na na-transfer na natin sila sa kabilang side. So, mag-change na yung sign. Minus 30, 12, 6 is equals, divided by 12. The answer is AX 176.67. Positive, so to the right. So, tama naman yung assumption natin na to the right yung AX. Okay. Dahil nakakuha na tayo ng isang vertical component at horizontal component, so pwede na natin gamitin yung summation of vertical or horizontal components para makuha yung mga unknowns dito sa point B. Now, solving for BY, so magsa-summation tayo at vertical forces is equal to 0, upwards is positive. Okay. So, AY, positive. 356.67. Then, negative 30 times 12. And then, positive dy plus dy is equals to 0. Okay. So, perhaps, ita-transfer natin sila na sa kabila. So, solving for by, negative 356.67 plus 30 times 12. By is 3.33 kN, kilonewton upward. Solving for Bx. We're using summation of horizontal forces is equals to 0. The right is positive. Okay. So, AX, 176.67 minus 200 plus bx. Kasi positive yung assumption natin sa bx is equals to 0 na. Solving for bx, negative 176.67 plus 200 is equals to bx is equals to 23.33. Then, checking to make sure kung tama yung answer. Checking tayo sa vertical forces. Okay. AY, 356.67 minus 30 times 12 plus BY na 3.33 is equals to 0. 356.67 minus 30, 12 plus 3.33 is equals to 0. So, check. Oh, another one. Summation of horizontal forces. X. Oh, AX, 176.67 minus 200 plus BX na 23.33. 176.67 minus 200 plus 23.33. 0. So, tama. Our second problem in equilibrium and support reactions, we have here problem 3.32. An arc that is supported by hinge at point A and at point B. At meron siyang internal hinge at point C. Before using the equilibrium equations, let's first classify this structure. Okay. R is equal to 3BSCE-C. External reactions are 4. 3 plus the 1 internal reaction 1. So 4 is equals to 4. Therefore, this is statically determinate. Now we can start applying the equations of equilibrium to determine the unknowns. Okay. Since hindi naman natin makukuha directly yung mga unknowns, so gagamit tayo ng dalawang equations tsaka i-equate or i-combine na lang natin para mahanap natin yung dalawang unknowns. So, unahin natin dito sa segment AC. Okay. Magmo-moment tayo sa point C. Counterclockwise is positive, summation of moment, segment AC, C. Okay. 24, kasi 24. 20 from AX, 24 feet, moment arm, okay. Direction is positive, kasi counterclockwise, okay. So, 24 AX, then AY, 12 plus 36, yung moment arm niya is 48. AY, then it is negative kasi counterclockwise. So, negative 48 AY, then yung 50, since clockwise naman siya, since counterclockwise, so positive. 50, then moment arm niya na 8 is equals to 0. Okay. 24 AX, okay. 24 AX minus 48 AY is equals to negative 50 times 8, 400. Negative 400. So, pwede natin silang lowest term. Okay. 400 divided by, let's say, negative 8. So, I'll divide them by negative 8. Okay. Negative 400 divided by 8. 50. 48 divided by 8. 6. Okay, 6. 6 AY. Then, 24 divided by 8. Okay, 3. Negative 3 AX plus 6 AY is equals to 50. So, ito yung equation 1 natin. So, kulang pa tayo ng isang equation. So, dito naman tayo mag-moment sa point B. Okay. Counterclockwise is positive. Summation of moment at point B is equals to 0. Okay. So, AX, moment arm niya is 12. And yung direction is counterclockwise, so positive. 12AX. Then, yung sa AY naman, yung moment arm niya is 12, 36, 14, 14. Okay. Negative 76 kasi clockwise siya. Negative 76 times AY, 12 AX. This is AX and this is AY. Okay. Then 50. It is clockwise, so negative 50. Moment arm niya na 4 plus, kasi 125 is counterclockwise. So 125 times its moment arm na 14. Okay. Is equals to 0. Combining like terms, 12AX minus 76AY is equals to negative 1,550. So, lowest term, pwede natin siya i-divide sa negative 2. Okay. 12AX, negative 6AX plus 38AY is equals to 775. So, ito yung equation number 2 natin. So, para makuha natin yung value ng AX tsaka AY, i-combine lang natin yung dalawang equation. So, simplify muna natin. Okay. Negative 3AX is equals to 50 minus 6AY. Para mas madali na lang siya i-plug in. Then, yung AY is equals to 775 plus 6AX. Then, yung 38, i-divide natin sila sa 38 para makansal yung 38 sa AY. 38 over 38. Now, mas madali na lang natin silang. Now, solving for AX, we have here negative 3AX is equals to 50 minus 6, the value of Y, 775 over 38 plus 6AX over 38. Magiging negative 3AX is equals to 50 minus negative 6 times 775 over 38 is 2,325 over 19. Negative 6 times 6AX over 38 is equals to negative 18 over 19AX. Okay. Now, transpose this AX para ma-combine sila. So, negative 3AX plus 18 over 19AX is equals to 1,300, negative 1,375 over 19. Solving for AX is equals to 1,375 over 19 divided by negative 3AX plus 18 over 19. So, our AX is 35.256. It is positive, so to the right. Okay. Now, solving for AY. AY is equals to, let's use this one, for equation number 2. AY is equals to 775 over 38 plus 6AX. So, the value of AX is 35.256 divided by 38. So solving for AY is equals to 775 divided by 38 plus 6 times 35.256 over 38. The answer is RAY is 25.96. 96. Since it is positive, meaning our assumption AY upwards is correct. So, okay. Now we're ready to solve for the unknowns in A and B, since we already have one horizontal and vertical reaction known. Okay. AX is equals to 35, let's just copy 235.256, and AY is equals to 25.96, 961 to be exact. Okay, upwards. Now let's solve for BX and BY at point B. Let's use the summation of horizontal components plus the 0. The right is positive. Okay, so AX, it is positive, so 35.256 plus 50, and our assumption for BX is negative, so negative BX is equals to 0. So solving for BX is equals to 35.256 plus 50 is equals to 85.256. Positive, so it is positive. It is positive, so our assumption is correct. It is to the left. Okay. Now to find our BY, summation of forces vertical equals to 0, upwards is positive. AY 25.961 minus 125 plus our assumption for BY is upward, so BY is equals to 0. Now solving for BY, 25 point in BY. So let's assume na we already transpose this to the negative side. So mag-change na yung sign nila. So negative 25 0.96 0.96 plus 125. BY is equals to 99.04 upwards. Now for our checking, summation of horizontal forces must be equal to 0. So AX 35.256 AX, then 50 kips and BX minus 85.256 equals to 35.256 plus 50 minus 85.256 equals to 0. For summation of vertical forces, 25 upwards is positive and to the right is positive. 25.961 fx ay ay minus 125 and by 99 plus 99.04 is equals 0. So that's for our problem 3.32. Gabbled frame supported by hinge on point A and point B with one internal hinge. Let's check first the determinacy of this one. So R is equals to 3 plus EC. External forces or external reaction is equals to 4, and 3 plus 1 internal hinge, 4 is equals to 4. Therefore, this is statically determinate. Now we can begin looking for the unknown reactions by using equations of equilibrium. Okay. The length here, 16.97, was obtained by square root of 12 squared plus 12 squared, 16.97. Okay. Now let's start. There are 4 unknowns, so we can use the summation of vertical and horizontal components here. We can only use moment, so let's have a moment at point B. Okay. Counterclockwise is positive. Summation of moment at point B is equals to 0. Okay. Negative 24 AY minus 20 times 12 na moment arm plus 1.5 times its length na 16.97 times its moment arm from the middle 18 plus another 1.5 times 16.97 times 6 moment arm from this one. Okay, is equals to 0. Solving for AY is equals to 15.46. Now let's find AX by moment equilibrium. Positive. Clockwise and counterclockwise is positive. Summation of moment segment AC point C is equals to 0. Okay. So point C, this is point C. We're only gonna deal with this segment to find AX. So 24 AX, kasi 24 yung moment arm na dito, minus 12, 15.46 AY, or AY, plus 20, moment arm niya is 12, plus 1.5 times its length na 16.97 times moment arm na 12. I mean 6 rather. 20, 12, 15, 16, 6. Kasi 6 siya dito. Okay. So, solving for AX, we have negative 8.63. Therefore, mali yung assumption natin sa AX na to the right siya. ang AX is magiging 8.63 to the left. The AX and the AY, we can now use the horizontal and vertical equations of equilibrium to find the unknowns at point B. So, for BY, summation of forces vertical, or Y, is equal to 0, upwards is positive. For all the vertical forces, AY, 15.46 minus 1.5 times 16.97 minus 1.5 16.97 plus BY is equals to 0. Solving for BY is equals 35.45. For last reaction BX, let's use the equation, horizontal equilibrium equation. F of x is equals to 0, the right is positive. So Fx Ax negative 8.63 plus 20 minus Bx is equals to 0. Solving for Bx is equals to 11.37. Since it is positive, our assumption is correct. So, for Bx 11.37 to the left, By 35.45 keeps upwards. For our Ax 8.63, to the left, keeps to the left, and for our AY is 15.46 keeps upward. We're checking. Now for the summation of forces horizontal, the right is positive, negative 8.63 plus 20 minus 11.37 is equals to negative 8.63 plus 20 minus 11.37 is equals to 0. Therefore, our answers are correct. Problem in equilibrium and support reaction. We have here a gable frame that is fixed on point A and point B. It has 3 internal hinges. So before we start with the equilibrium equations, let's classify this structure first. R is equals to 3 plus EC. The external reactions is 3 per point A and point B. So we have 6 external reactions and 3 plus 3 hinge. So 6 is equals to 6. Therefore, this frame is statically determinate. Now we can start with our equations. We have a diagonal forces here, so let's find out the angle first. So if this is 15 and this is 10, therefore the angle is 33.69 degree. And the length of the hypotenuse is 18.03. The force here, 36.06 kips, was obtained by multiplying 2 kips per feet by the length, 18.03 feet, equals 36.06 kips. And for this one, 18.03, again, let's just multiply them. 1 to the length of the hypotenuse, 18.03. So, 18.03 feet multiplied by 1 kips per feet. Therefore, meron na tayong 18.03 kips dito na diagonal force, yung sa ED. Okay? So, proceed. So, ito yung ating free body diagram. Pinaghiwalay natin para mas madali siyang isolve. Kasi meron siyang dalawang internal hinge dito. So, mag-start muna tayo sa portion CED. Yung ito, C, E, at saka D. So, gumamit tayo ng moment equilibrium equation. So, dito muna tayo na portion. Counterclockwise is positive. Summation of moment at point D is equals to 0. So, 0. Point D is equals to 0. Summation of moment at point D is equals to 0. Dito lang muna tayo sa taas. So, sa CY, 30 CY minus 2 feet, 2 times 10, distance niya na 10, or length rather, 10 times yung moment arm niya na 15, minus dito yung 36, minus 36.06 yung kanyang sine, kanyang vertical components ng 36.06 kasi diagonal siya. So, hanapin natin, ilagay natin yung kanyang vertical tsaka horizontal components. So, sa kanyang vertical components, ito ay 36.06 times sine 33.69 yung angle times moment arm 15 at para sa kanyang horizontal component is 36.06 cos angle 33.69 degree times moment arm na 22.5 minus 18 dito 18.03 sine 33.69. Ito yung yung vertical component ng 18 dito times 15 minus, kasi negative siya or clockwise yung rotation, 18.03. Ito yung horizontal component, cosine 33.69 degree. At yung moment arm niya na 7.5. 15 divided by 2. Okay, so solving for our CY, CY is equals to 1.25 kips. Okay. So, iligay na lang muna natin dito. CY is equals to 1.25 kips upwards because it's positive. Or, no, it is downward kasi yung assumption natin is downward siya. So, tama yung assumption natin. Now, solving naman for CX using this segment pa rin. So, summation of moment at segment CE dito at point E is equals to 0. So, CX. Negative CX, moment arm niya is 20 plus 1.25 yung ating CY na may moment arm na 15 or yung distance niya from point E 1.25 times 15 plus 2 times 10. Ito yung 2. Yung uniformly distributed load na 2. At yung length niya na 10. Tsaka yung moment arm niya na 15. Plus yung 36. 36.06 at yung length niya na 9.015 is equals to 0. So solving for CX, we have 32.19 kips. Okay, so ilagay natin dito. So CX is equals to 32.19 kips. So, ibig sabihin, tama ulit yung ating assumption na to the left yung CX. Okay. Next. Nakikita na natin yung CX tsaka yung CY dito. So, considering considering segment CED pa rin. So, pwede na tayong gumamit ng yung summation of vertical forces. So, upwards is positive. So, summation of vertical forces 0. Yung sa considering portion CED pa rin to. Okay. So, negative 1.25 since CY is downward. So, negative 1.25 minus yung vertical component ng 36.06. So, 36.06 tsaka yung length niya na cos 33.69 degree plus dito 18.03 cos 33.69 plus dy is equals to 0. So, solving for dy is equals to 16.25. Our dy is 16.25. So, our assumption here, our dy is upward. So, tama yung assumption. And, ilagay na natin siya ito. dy is equals to ating dy is 16.25 kips upwards. Okay, tama yung assumption natin. So, another one for our segment CED. Okay, segment CED, summation of horizontal forces is equals to 0, to the right is positive. So, yung Cx is 32, so magiging negative 32.19 plus, again, yung ating uniformly distributed load dito, 2 times slant na 10 plus yung horizontal component ng 36.06 na 36.06 times sine 33.69 plus 18.03 yung dito at yung length niya na sine 33.69 plus yung sa uniformly distributed load natin na 1 kips per fit, so plus 1 times 10 kasi length is 10. So, yung assumption natin sa dx is to the left siya. So, negative dx. Now, solving for our dx is 27.81 kips. Okay. So, dx is equal to 27.81 kips for this case. Then, dx is tama yung ating assumption na to the left siya. Okay. Dahil nakuha na natin yung mga reaction sa segment CED ng ating frame, pwede na tayong mag-proceed sa paghanap ng reaction sa ating point A at point B. So, yung sa C and D, di ba nakahanap tayo ng kanilang reaction. So, ang magiging reaction niya sa C and D sa segment A at B is yung opposite. So, yung pababang CY dito, magiging pataas siya dito sa segment A and B. Tsaka CX, kasi to the left siya dito, meaning dito na sa segment AB is magiging positive siya, and so on. Okay? Now that we know the internal reactions at CY, CX, DY, and DX, we're ready to find the unknown at portion AC. So, at portion AC, so our free body diagram here at portion AC, AC, these are our assumption for the direction of the forces. This is the distributed load, 1 kips per fit, and the opposite of CY and CX. CY is downward, so our CY here is upwards, then CX to the right. Okay. So, to the right is positive. Summation of forces horizontal is equals to 0. So, negative AX plus 2 times 10. So, 2 times 10 kasi may 1 dito tsaka may 1 dito. So, kinumpay na lang natin para isahan na lang. Then, plus 32.19 yung sa CX is equals to 0. So, solving for AX is equals to 52.19 kips. Now, for the vertical component, upwards is positive. So, summation of vertical components y is equals to 0. Negative AY, kasi yung assumption is negative siya dito, or downwards, plus 1.25 sa CY. Dito. Okay. Is equals to 0. Now, solving for AY is equals to 1.25 downwards. Downwards yung assumption. So, hindi siya nag-negative. So, positive. Tama yung assumption natin. Tsaka sa AX, 52.19 kips. Yung assumption natin is negative. I to the left. So, tama rin yung ating assumption. Okay. So, AX is equals to 52.19 kips. AX. AY is equals to 1.25 kips downward. Now that we have the horizontal and vertical components of point A, we are now ready to find the moment at A. Okay, so counterclockwise is positive. Summation of moment at A is equals to 0. Okay, moment at A minus, okay, 2 times 10 and yung moment arm niya na 5 minus yung CX, yung sa CX na 32.19 and moment arm niya na 10 is equals to 0. So, solving for moment at A is equals to 421.9 kips per feet. Oy, sorry. Kips per feet. At saka yung assumption is counterclockwise siya. So, tama yung ating assumption. And A is equals to 4. Now that we're done with the portion C, AC, okay, now that we're done with the portion AC, let's now proceed to the free body diagram of portion BD. So, mag-draw tayo ng free body diagram. Yep. BD. Yung assumption natin sa forces is point B and point D. 1 kips per feet. At yung sa dy niya is 16.25. 16.25 dy. Oh, downwards. Kasi upwards yung sa CED. So, maging 16.25 downwards. Then, yung sa dx is 27.81 to the right. 27.81 to the right. Okay. Same with the previous process. Let's find the vertical components at segment BD. summation of vertical forces, y, is equals to 0. Upwards is positive. So, by, dx. Okay. So, by minus 16.25 is equals to 0. Solving for by, our by is equals to 16.25 upwards. Okay. by is equals to 16.25 upwards. Now, solving for the horizontal component of segment PD, E of x, summation of fx, 0 to the right is positive. To the left man yung bx, so negative bx plus yung ating uniformly distributed load na 1 kips per feet times 10, yung kanyang length, plus yung ating dx na 27.81 is equals to 0. So, solving for bx is equals to 37.81. And yung assumption natin is to the left siya. So, positive naman yung answer. So, tama yung ating assumption. Okay. For bx, we have 37.81. Lastly, let's find a moment at B. Okay. Counterclockwise is positive. Summation of moment B is equals to 0. Okay. Moment at B minus, okay. The rotation of this uniformly distributed load is clockwise, so it is negative. Then times 5, the moment arm, minus 27.81, and 10 moment, 10 feet na moment arm. So, solving for moment at B is equals to 328.1 kips feet, and our assumption here is counterclockwise. So, it is still counterclockwise because hindi naman siya nag-negative. So, we have now moment at B is equals to 328.1 feet dx. Okay.